B8, last one, right? So what mass of sodium formate must be dissolved in 0.3 liters of 0.25 molarity formic acid to produce a solution with pH 5.09? And then we're given the Ka value in this case. So again, right, this is a buffer problem. We can just simply use the Henderson-Hasselbalch equation if we wanted to in this scenario. So to do that, right, what we can do is, right, that equation is is pH equals pKa plus the log of the base, over the concentration of the acid in that scenario. And so now we know what the concentration is of the acid. We just need to now figure out what the concentration of the base is supposed to be, right? And we're trying to get what the mass is, right? We're trying to get the mass of the sodium formate. Or no, that's not sodium formate, right? That's sodium acetate. My bad. Right? So that's what we're looking for, right? So the first thing that we need to calculate is what concentration of A- we need to have, because that's going to tell us, what's going on. So the easiest, right, because we know what the pH is, that's 5.09. The pKa we can calculate because we're given the Ka. And we know what the concentration of HA is, right? So we just have to now, essentially back calculate our way to what the concentration of A- is. Once we know the concentration of A-, we can calculate how many moles we need. Once we know how many moles we need, right, we can calculate how many grams we need in that case, right? So it's just a small step process. So the first thing to do, right, is going to be to calculate the pKa, right? So the pKa is equal to the negative log of the Ka. So plugging in our values, right, we have the negative log of 1.8 times 10 to the negative fifth. Negative fifth. So what we get is 4.74, right? That's what the pKa is. So now what we can do is rearrange everything, right? So the first, what we can do is we can figure out what the ratio is that we need. So the ratio of A- over HA, right? That's going to be equal to 10 to the power of pH minus pKa. So this is very similar to what we had done in problem B9 earlier, right? But we can plug in our values that we have now. In this case, right, so the pH that we want is 5.09 minus the pKa, which is 4.74. Right, so what that gives us is 10 to the power of 5.09 minus 4.74 gives us a ratio of 2.24 in this case, right? So that's the ratio that we want. So that's going to be equal to the concentration of A- over the concentration of the acid in that case. So we can rearrange this now, right? And so what we can have is just simply that the concentration of the base is going to have to be 2.24 times the concentration of the acid, right? So we have 2.24 times the concentration of the acid, right? It's going to be equal to the concentration of the base. And so now if we plug in our values, right, we have 2.24 times the concentration of the acid, which is 0.25 molar. Right? And so that's going to be equal to 2.24 times 0.25, 0.56 molarity, right? That's the concentration now of our base. So we know that now. So now to figure out how many moles we need, right? We have moles of, I'm just going to continue to refer to it as A-, right? That's going to just simply then be the concentration of A- times the volume, right? And so we know the concentration now. So that's 0.56 molarity, and that's going to then be multiplied by the volume. So the volume in this case is 0.3 liters. So the number of moles is 0.56 times 0.3 is 0.168 moles, right? So we have that right there. And so now we just need to figure out what the mass is, right? And so the mass of the sodium acetate, right, is going to be equal to the number of moles times the molecular weight. So that's going to be 0.168 moles times. So the molecular weight is, what's sodium, like 23, I think? Yeah, 23 or 22.99. I'll do 22.99. 22.99 plus 12.01 plus 3 times 1.01 plus 12.01 plus 16 times 2 comes out to 82.04 grams per mole, right? Moles cancel, so we end up with grams. So what we get is 0.168 times 82.04 gives us 13.78 grams, right? So 13.8 grams, 13.78 grams, which I believe matches what I have in the key. 13.8 grams. Yep, exactly. So, right. So that's how you approach